Hi, I'm going to get started. It's 4 o'clock. Somebody has to go last, so I'm happy and honored that you are here. I mean, this is like great. One of the things I want to say about myself before I get started is I was looking at my Philly ETE bio, and it says object pioneer. You know, pioneers are usually people who have arrows in their back. You know, they go through a lot of struggle. But I've done more since then. You know, I wrote a book about object design in the 1990s that is still in print, which is like amazes me. But anyway, since about 1995, I've been involved in I have a foot in the Agile community as well. I actually go wherever people want to care about and talk about design and do good design. So I have experience in both Agile and non-Agile worlds, and I'm not biased. I like good, thoughtful people wherever they may be. So anyway, this talk is about why we need architects and architecture on Agile projects. And just so that I get a sense of, how many of you are working on Agile projects? Wow, most. Okay, so that's good. Do you have anyone on your projects that has a role of architect? Some fewer. Are you that person or not? Oh, okay. Okay, now for the rest of you, this talk is for you too. One of the interesting things to talk about, and I hope to answer these 3 questions in this talk is, okay, what's the role of an Agile architect? Someone who cares about the architecture. You know, I put the word Agile there as an adjective, in that I think they are somewhat different than traditional architecture roles. And then how much architecting do you really need to do? Whoops, I'm going to say, basically, one of the things that I want to think about is what's the role of an architect? How much architecting do you need to do and when? My animation's screwed up, so I'm looking at this a little differently than you are on the screen. And then what are some practices you can do, whether you're on a small team or a larger team, that enforce, you know, sustainable architecture? So those are the 3 things I want to talk about. Now, how many of you have heard of Joel Spolsky, right? He talks about, you know, one of the things why architects get a bad rap is, you know, Joel's written about the astronaut as architect. Someone who is so floating above reality that they're thinking about product visions out in the future that they might as well be in outer space because they're useless, right? So that he comes from a bias that says architects, what's wrong with those bloody architects is that they're not doing anything that's useful. And so I think that these days architecture gets a bad rap in a lot of places. And another kind of bad, all right, you know what seagulls do, right? They squawk a lot. When they notice something interesting, like food, they'll come in, fight over it, squawk, poop, and leave, right? All right. So the architect who comes in and says, you're doing it wrong, no, you need to do it this way, whatever, and then walks away and doesn't help, but creates a mess and a chaos in a project isn't good either, right? So, I mean, there are reasons why misbehaviors, if you will, of architects sometimes get exaggerated. We like to blame, you know, and characterize people. The other thing, this happens to be a picture of a bridge project and a road project in Oregon on Highway 20 between the coast and the Willamette Valley. That, you know, we all like to build infrastructure. Well, this Toledo road project never got finished, right? They built the infrastructure and then they discovered that the mountain wasn't stable that they were trying to go over, and so things fell down. And so when you get to the sense of the kind of architects there, you might say, well, what were those incompetent fools trying to do? You know, build something over unstable ground in the Pacific Northwest in the Coast Range where it rains a lot, and they should have known this. So architects, whether they're building architects or software architects, sometimes get a bad rap. And I tend to think that those are not necessarily well-deserved. So I want to talk about a role of an Agile architect and what practices we can do. And in some sense, and I hope none of you have to balance on chairs like this at work every day, but when we think about what makes for a good system, you have to think about the design values. And I think there are a number of core values that traditionally have been associated with Agile development, in that we value design simplicity. That doesn't mean simplistic. It means not overly complicated, right? In that, also that sustainable systems. You've heard about sustainable pace. Well, in order to do that, our systems and our software that we're building and our infrastructure have to be able to grow and evolve as our systems grow and evolve and add more features. Nothing ever gets simpler. It always gets more complicated. That whatever we do and the decisions we make on the ground, given the investigations we have and what we know and what we've built, are not going to be right 3 years from now. They just aren't, right? So we're going to have to constantly improve just to keep at the level of being competent and sustainable. We have to improve. I hope none of you are still running stuff in IE6, right? You need to improve if you're there on some of your platforms. The other thing about Agile design values is that it's more of a team sport. It isn't that we don't have team leads or tech leads, but that teamwork is part of it. It isn't considered good form for someone to go away and come back with the stone tablets of here's how we do it and say, here, team, just do this. That doesn't happen very well and doesn't go over very well with Agile teams. And so there's a great need for communication and trust. So if I say this isn't the way we should be doing something, you should have trust and respect to me to listen and respond to that as well. We don't just build things because it's fun, but we try to satisfy stakeholder needs, but sometimes there's fun stuff too. I mean, don't get me wrong. On the other hand, if we stop learning, it's not a good thing. So we're also in a constant learning mode. So given those design values, here's what I've seen that some people have said about Agile and architecture. They say, well, simple solutions are always best. I mean, have you heard that kind of expression? Simple is best. Well, given that I have 2 or 3 alternatives, I might challenge you to say simple may not always be best. If I know 3 things about it and one is slightly more complicated, but it's going to handle edge cases that I really know, maybe that's better. Okay. There's also the myth that if I build in flexibility into a system, that's over-engineering. You've heard about you aren't going to need it. Okay. Maybe you aren't. But if you have the use cases that drive you to build flexibility into a system because you know something is changing, why would you build it in an inflexible way, right? Okay. Would you? I mean, I wouldn't. Otherwise, how would we ever get frameworks, right? Frameworks are designed for a range of uses, and they have some flexibility in them, right? So these, the other thing that I've seen on teams as I've gone around is we don't need no stinking specialist. Johanna Rothman has talked about Well, ideally, everyone on a team should be a generalizing specialist, which means, yeah, you might have an area of expertise, but you ought to be able to do anything. You may want to pitch in, but I do think that we do need specialists. I certainly wouldn't want to trust security just to everyone. You know, gee, we'll just, yeah, okay, you learned about SQL injection, our systems are now secure. Not. Okay. And then there's also this, I think it's just, do people really believe this? It's a wishful hope by some management that says, if we're agile, we can just adapt, right? We're agile. So we can change things out, no problem. Any new requirement, whether it's going to destroy our architecture, we can adapt. You know, you're smart, you're agile. Come on, guys. So don't worry about architecture. It's just going to emerge. It's going to be okay. All right. So those are some of the, you know, bad rap that you get about architecture. And given those agile design values, which architects and people with those kinds of roles should support, I want to talk about a role and some roles and activities of architects, whether it's an individual that's a tech lead on a team or someone who has a job title of, you know, technical architect or solution architect. Oftentimes, someone who has an architectural role plays the role of a wayfinder. If I have two paths into the woods, which one should I take, right? Maybe I want to avoid the woods, so I'll take the one to the right, right? Maybe that's so obvious, but maybe I don't know that. And so wayfinders are looking just enough ahead to figure things out in the context of what we're going to do next. They're active, and they integrate what's on the ground. So it isn't theory, it isn't just looking at specs, but it's what are we doing, what are we building now, where are we going, where are we headed, how are the troops doing, how are we doing, how's our money, you know, all those things, not just technical concerns. And, you know, exploring options. And coming to, you know, I liked Dave Thomas's talk this morning when he talked about tacit knowledge. I think that oftentimes exploring options without being able to explain why can be a problem. So we may have tacit knowledge, but as someone with an architecture role, we need to be able to explain and persuade. So we have to at least be, I don't say good salespeople for our ideas or give them evidence. So I also, this is a picture of a shepherd on the hillside in Romania, okay? So that I think that another role of architect is being a steward in that, and it's not a wizened old man, but I mean, always. But what I want to say is this is also not a sheepdog either. Have you seen sheepdogs in action? They're like nipping at the heels. They're hyperactive, annoying, irritating, trying to get the sheep to go all in a certain direction. This guy isn't doing that, is he? Right? He's amongst the flock, and he's taking care to make sure that no animal is getting hurt, or that there isn't a situation that you know, since sheep happen to be flocking animals, that they're all following something over the edge of a cliff. I happen to have had a 4-H lamb when I was in high school, or junior high, and I named him Catch-em, because it was very hard to catch him. And it was interesting to me that not all sheep are alike. My brother's lamb was very docile, and as a result, after selling the lamb, for 4-H you have to sell your animals and they get eaten, you know, to someone. He was a vegetarian for 5 years, right? Me, when I had my lamb and it was sold, since it was sort of unruly, I sort of thought, well, okay, it's had a good life, but because it wasn't my friend, but I was still steward. You know, I had to, that lamb knew how to get out of our pasture. And so someone as a steward is taking care and is in the field, is not in the ivory tower. So this is my friend Francisco Cirillo, who a couple of years ago visited Portland, spent some time with Ward Cunningham, and then spent the weekend at our house. And he is the consummate guy who's a really great design thinker, but he's also was professionally trained as a chef. And so he had to cook for us, cook for me, some food that he just didn't believe could be made into something that would taste very good. He's from Italy. And I said, we have this thing called spaghetti squash, and it really does taste like spaghetti. And he says, oh no, I can't believe it. So he used ingredients that he'd never used before. He used his skills, and he had me do some of the grunt work. I think that, you know, the idea of a steward is someone who's cares about sustainability and follow through. So it wasn't enough that I just gave him the ingredients. In fact, my garlic was too old for him, so I had to go buy new garlic at the store, right? He cared about the quality. So he paid attention to the little details, and that was one of the tastiest meals that I've had in a long time. He made soup, and he made the marinara sauce and the spaghetti squash. I cooked the spaghetti squash. That was my task. So stewardship in an architectural sense is not just being there on the ground, but it's follow through and finding those small little details that matter and worrying about them. And another thing that I think is making what's difficult or tedious, if it's in the programming realm of delivering features, easier. So good architects that I know are also some people who really care about how are we building, how are we doing things, is it hard, is it too easy, is it error prone, is it boring as hell and I could write some code to make this automated? They're looking at things like that as well. So Alistair Coburn has had, for his crystal methodologies, talks about how much ceremony you need based on project criticality and size being all the people involved, right? And so he has he has like 4 degrees of criticality. A comfort project is like an app you build for the App Store over the weekend. We're not going to lose sleep if Philly ETE app doesn't work that well. I mean, maybe we will. Maybe someone will complain, but so what? Discretionary money are projects that if you fail, your company won't collapse, but it's not a good thing. You've lost some money. Essential money means you're pretty hurt if that project fails. And a life-critical project is, and I don't know if any of you work on projects like that, if the project fails, people may lose their lives. Anybody work on software and systems like that? Okay. So again, then there's this other axis of project size. And so Alistair uses this to think about how much ceremony, how much gates we need, those kind of things. But I found it useful to consider how much, not just tacit, it just happens architecture, but how much explicit architecture do we need to think about. And I would certainly say, even if it was a small project and it's life critical, we may be doing a lot of architecting very explicitly, not just let it roll along. On the other hand, when there's money involved and lots of people, if you aren't doing architecture activities in a conscious way, that can be problematic too, right? So there's this balance you need to think about. Any good architecture, whether it's for a small system or a very large one, has to be pragmatic. It does, and what I mean by that is it's doing what it needs to do, whether it's performance or scalability kind of requirements, or whether it's data throughput, or whether it's the usability, without a lot of extras. It's in the Agile world, it's also designed for test. An architecture where properties of it can't be tested is kind of not really a good thing. And so I also think that it has some kind of organization and structure, and it doesn't have an unintentional redundancy or overlapping functionality. Now, if you're on a big, large project, what I don't mean is we refactor down and get everything so there isn't any overlapping functionality, but we do the best we can, because the more places and corners of a complex system there are that are redundant, the harder it is to know what's going on. And then it has to support these kind of architectural goals that you have. Now, so given that, I'm going to talk about small team practices and larger team practices that I have seen. So what's small? Given that we've thought about seeing Alistair's grid, you could talk about the size, but you can also talk about the complexity or the criticality as well. But small projects are typically 6 to 8 people. They're non-life critical. So if you screw up, the architecture for small teams is, oftentimes evolves without any little extra attention, because the whole team is competent. There's not a lot of extra communication channels that have to go on, and if they're at all competent in the technology, they kind of know what they're doing. How many of you work on small projects? Isn't it nice? Yeah. When you work on large projects, the world is very different. We're divided into teams. Functional teams, maybe even technology area teams. And what I have found is that naturally emerging architecture can reflect the organization structure. So I don't know, the group here in California is doing this, and it's communicating with something designed by the group in Atlanta, and they're working on that. And so things gonna get geographically distributed, whether that's a good architecture or not. And so that may or may not be a good thing, right? That the architecture reflecting the structure of the organization. And usually for larger projects, there are risks, challenges, unknown, all this coordination. Nobody knows everybody on the project. In fact, you have all these potential paths of communication, but who's doing what and how are things going along, and how are features affecting other features and components and infrastructure affecting these things may not be really very clear. So large projects, just by their nature, have a lot more moving parts and complexity. So I want to talk about if you're a few people that are doing small projects, there are some practices that we consider pretty common for Agile teams that naturally reinforce architectural excellence. They don't guarantee it, but if I don't know what to do, I can do a design spike, right? It's like, I don't know how many people have forgotten this, but there used to be I estimate my work, I break it down into tasks. As a developer if I'm doing XP or something like that within a Scrum project, if I don't know how to do something, I don't just sit there and twiddle my thumbs. I declare I have a design spike, right? It says, I don't know what to do. We've forgotten that we used to have these things called design spikes. And what that means is that I'm taking myself off of the delivery path for a little bit of time. I may take a few hours to as much as a few days. And I may use exploratory coding that I'm willing to throw away. I may do sketching. I may do, I call it research or looking around, going outside, seeing what my Google explorations. I may do some lightweight modeling of things. I just throw up CRC cards there to figure out an approach, and I may fail, right? But I take it off the path, declare that I have a spike. I may even get other people involved to help me do that. So I'll just keep slugging away and committing every little thing if I don't know how to do it. So design spikes are things that are typically within the team's purview. Anyone within a team can declare it's a design spike, and we have to go figure things out. And they may or may not communicate that outside of their team. But if they don't know how to do it, someone has a task, they stop and go do some noodling around to figure it out. Usually, if you're doing stuff like that, you experiment on branches, right? So if I know that a trendy thing in some Agile groups is to have only one main branch, right? All right, every last little thing we're doing is committing whatever, every last little test, everything. But if I'm doing a design spike, I consider it a best practice to take it away, not commit, maybe a few hours. When I am done with my design spike, I'll learn something that may succeed or not. So I have the option of failure, spike. So the other thing, if I'm going to be a learning designer and sustainable pace of my development, is that I want to incrementally refine things. So if I find a better way of doing it, I will do refactoring. So there's really two kinds of refactoring. Emerson Murphy-Hill was a student at Portland State. He wrote a paper with Andrew Black. So we're from the Portland area, know these guys. And they actually investigated how people were using refactoring tools because they instrumented the Eclipse environment to see what people were doing. And actually, it turns out that people aren't using refactoring tools as much as you would think. That was kind of sad, what they found. But they also found that there were really two kinds of refactorings, and they called them daily refactorings, which are like flossing. We should all do it daily, right? And those happen with certain teams. And then there are those refactorings where you discover that it's like, that tooth isn't, the pain isn't going to go away by just flossing. I need more restructuring. I may need a root canal. So they call those root canal refactorings. Now, it turns out that those kinds of simple daily refactorings are the easy ones, right? Because if you keep it clean and refine things as you go, when you spot duplications or a more efficient way of doing it, you're reflecting your learning back in. But sometimes you need to pause and do these larger root canal refactorings, right? So in some sense, what we're trying to do if we're sustaining our architecture on a small team is to manage our debt and to reflect our learning back into our code. And it isn't that we're being sloppy, at least I don't have that belief, when we're accruing debt. It's that we're finding out better ways of doing things that are more efficient, more economical, not so squirrely. I know that the first time I built and implemented my REST interface using a particular Java framework, which shall remain unnamed, that I didn't do it in the most efficient way, right? And once I figured out that I could do it more efficiently, I went back and rewrote the code. It worked, but it was just ugly, and it wasn't the pattern we should be following. Okay, so that's an example of if I learn a better way, I take the time to clean up as I go. Because it can have long-term consequences, particularly if one set of REST services are implemented this way and another are implemented another way, and then, well, what's the right way, and what happens when they break, and what are we going to do? So the other thing to think about for small team practices is that all tasks that you take off your backlog are not alike. What I've found is there are 3 different types of tasks. Those that are core, that are fundamental to the project's success. And those that are, yeah, it's something we have to implement. Maybe we don't even have to design for. It requires a lot less creativity and inspiration, but it might be a drudgery, but there's a lot of that REST crufty stuff that isn't, you know, a design challenge or isn't going to break our architecture, but we just have to do it, right? And then there are these, oftentimes, this doesn't even happen on small projects, but sometimes you get challenges that are so revealing into that you fundamentally have to rethink the way you're doing something, right? When we have to turn our design ideas on their head and try a totally different approach. Okay, so if I'm aware of these kind of tasks, oftentimes I like to think about sorting the tasks and in a backlog into a problem bucket, the core and the rest. I can never do these revealing tasks because I don't know what the gotchas are going to be. They're going to hit me over the head when they happen. So I want to make sure, just so that I have this sustainable pace of making sure enough of that core foundational stuff gets built out. Otherwise, I'm just doing this drudgery, easy stuff. Might have great velocity, but crap architecture and nothing that can sustain me. And if there are design issues, performance issues, consistency issues, again, since we value teamwork, getting that team involved on those core issues, particularly if it's changing our foundations. And then something I like to do is we oftentimes have post-iteration retrospectives. And oftentimes you say, well, how happy were you with a feature or whatever? But I also like to, as a development team, ask, why were things harder than they appear? And maybe we weren't working on the right stuff. There's nothing that says that the backlog doesn't include technical items that need to get done as well. There was no golden rule or 10 commandments that said it only is done by the product owner. Just to sum up about the small team practices, we do these things so that we can integrate learning into our code and keep things clean and sustainable. We want tests for functionality, but we also shouldn't ignore tests for architectural qualities, performance, reliability, security, those sorts of things. So oftentimes, I know that small team projects, they go, well, great, we have our unit tests. Do you have your security tests? Do you have your performance tests? Do you know what you're scaling when you add more users? No. Okay. All right, so sustainable development really is paying attention to architecture and not only feature implementation. So that also includes, besides am I scaling, am I handling the load that I expect, design consistency, in my opinion. So this is how we do certain things. Our coding standards, the way we use logs, the way we throw exceptions, the way we handle errors, the way we handle authorization. If we're doing services, how are we doing authentication? How are we doing, anyway, here's the way we do things, developing those things. And then if there's parts of the code that are critical to the success of the architecture, and they're tricky. I don't know how many of you went to the Java 8 streaming talk today. I did, and I went, you know, I think I would like to have some steward review the code for that high-performance streaming stuff before we just, you know, bet the store on that. So if you have architecturally critical code areas, it's not like the collective code ownership. Anybody can go in and muck around, all right? That there is a steward. There is, maybe it's a set of people, but it's people who have the skill and expertise to guarantee that that qualities are preserved in that code. So I know we've talked about collective ownership on Agile projects, but stewardship is something more. It says we're paying attention, you know, to this. So I've known some teams where, you know, how do you decide what is architecturally significant? Well, when things totally blow you out of the water in production, that's a good sign, right? You made this change and your whole system blows up. So then they instituted a policy, and this is a small team, where anything that was dealing with the threading control, you couldn't just change it right before the release, you know. They had the whole team look at it. So they had stewardship on areas where they were affecting threading and control issues, because it was hard to write tests for those things. Okay, so I want to move on to larger projects. So the bigger the project, the more there's to consider. And even though some people like to believe that Agile will solve all problems, it doesn't guarantee that you can make significant architecture changes at the last moment, or that good architecture automatically emerges from good design and development practices. Doesn't always happen. I've seen good designs go over the cliff architecturally. Sometimes you need to do more. So I want to quickly run through a potential set of practices that you might consider for larger projects, and realize that you need to strike a balance. If you are looking at a potential practice here that is intriguing, my advice to you is go try it. You know, do an experiment. If you have architecture under control, great. You know, don't you know, keep doing what you're doing. So some decisions are important that set a path, and so one of the things that is a hallmark of Agile stuff is choosing the last responsible moment. You've heard that? Sometimes I think that we misbehave when we operate under that premise. I know that if I won't say lazy, but if I'm kind of sloppy about it, the last responsible moment is a minute too late. All right. So I'm saying for larger teams and projects, you need to consider about choosing responsible moments that strike that balance. And there's some practices you can do. I mean, there's a lot of different types of project risks, but I'm going to focus on technical risks where things are too complicated, poorly defined, or misunderstood, because they can screw you up. Now, we've heard about technical debt, but architectural debt, and I think that Grady Booch coined this term, is compromises that are very expensive to reverse. Okay. So if I've gone down a certain pathway, let's say Ruby on Rails is just it for me, right? And then I find it doesn't scale. I mean, that's a bad, maybe that's a bad example because you're using Ruby on Rails and it's working just fine for you. But if I choose something that has, doesn't work, and I keep pushing on it and pushing on it and pushing on it, it's going to be harder and harder to reverse. So typically things that involve architectural debt are things that are not isolated either. It's like, oh, this is how we're doing services. We're going to orchestrate all our services, you know, all these things that, well, are you really? And, you know, ignoring scalability, choosing and using frameworks poorly. I come from a lot of the Java world where that's all too easy to do. And once we learn that damn framework, we're going to keep using it, you know. Right? Spring, man, we figured out how to do those automatic queries. Never mind. Okay. We figured out how to use that cache. Never mind. Okay. All right. So poor framing choices or inconsistent service interfaces, these things, or even not even paying attention to your service relationships between things, can cause a lot of chaos. So additional projects, the larger projects I see, I'm going to go through some of these techniques very quickly, but I just want to make, since I'm not going to talk about this any further, is the notion of set-based design. How many of you heard about set-based design? How many of you have ever practiced it? Okay. I know of very few people who do this, but we were going to have a client that I had a single sign-on goal, right? And they used set-based design to determine the component that would do that. And it was the right thing to do, which was essentially putting it through a set of use cases, trying to eliminate a decision as quickly as you could before you finally picked the optimum choice. And so this was an architectural task that Colleen, this architect that I know, worked on. And this was kind of like the heartbeat of the system. And so, you know, coming from a very rich Java ecosystem, they had to get it right. It didn't take them forever, but the idea was to perform experiments and instrumentation before, so you could throw something out, eliminate as quickly as possible your alternatives so you can, you know, hone in on another one. So that's what set-based design is. Another thing to be aware of is that understanding on an architectural system the rate of what changes. Now, Steward Brand, who's written the book How Buildings Learn, talks about physical buildings evolving at different rates because the various different parts of them, or layers, as he calls them, gee, doesn't that sound similar to software terminology, has its own value and speed of change, or what he calls pace. And so he talks about there's the site, you know, that shouldn't change very much unless you're in the liquid land of San Francisco, right? The structure, the skin, which is the you know, bricks on the wall, there's a service layer that's in between that and the space on the inside, and then space plan, and then the stuff within it. And if you want buildings to go really, really fast, you know, even the rooms here are adaptable to some degree, but, you know, because these can slide in and slide out. So he says that buildings adapt because they've been designed and architected so that faster layers are not obstructed by slower ones. Sounds like software, yeah? Okay. The big ball of mud guys aren't really talking about how to do stuff wrong. They're talking about what to deal with when things are messy. So actually in the big ball of mud pattern paper, they talk about factor your system so that things that change at similar rates are together. And I've been collaborating with Joe Yoder for several years and drew this sort of picture that these things change faster and are easier to adapt than, you know, it's harder usually to move the platform out from underneath you, even if you think that you have a common API to the database, you still are. Anyway, not so easy. Infrastructure is harder to change. And so if you not only organize it, but design it so that the rates of change that you see are supporting things that need to change and they're not obstructed, that's a good practice. So another thing to think about is that some Agile projects that are larger happen to have a roadmap, which means that they have a plan for a plan. They expect that over the next period of time, whether it's 3 months or 6 months, we're going to deliver roughly these sets of features. And maybe a roadmap that it's where you expect to go. It can be at a coarse-grained level, or it can be very fine, like a story map. I don't know if you've heard of story mapping. And the relative time when certain features are needed. Now, if I have such a thing that's been laid out as an architect, I'm going to use the roadmap to determine what kind of architectural work and infrastructure work is going to need to support that feature development, right? And so if I know that this path, I live in Sherwood and I'm trying to go to the Portland airport, as you can see, I'll point out to you, there's like two major paths to the airport, one going this way and one going this way. It turns out there's a river, the Willamette River, and there aren't very many bridges over the river. So you have to make a choice fairly soon here whether you want to go through downtown Portland or the longer way around based on the traffic, right? So if I have a roadmap, seeing what features are ahead, I'm going to make architectural decisions that support the path that we're heading on, and I'm going to plan for those kind of activities. One way to track that we're making progress and not backtracking is the notion of a landing zone. Now, landing zone is different than a bag full of acceptance criteria, but it's a handful of poignant values that are indicators of our project and architecture success. So a landing zone can have a range of values. Think of it as a dashboard for project management as well as architects, if it has architecturally relevant values in there, that you can monitor and see as you're going along, how are we achieving what's going on. We need some slack. We don't always have a one number for a performance target. And so typically landing zone values have, for a success criteria, minimal values, which mean you can live with that, acceptable targets, what we're aiming for, and outstanding, this would be great if everything goes well. And so you could do it for any sort of system quality, and I've used them on large projects where we have performance, usability, reliability, like number of transactions, certain kinds of workflows, latency, depends on what the characteristics we're trying to do. And they're broader in scope than a single acceptance criteria. It may be for order processing transactions or these certain kinds of workflows. But they should be measurable, achievable, and relevant, and we can measure them. Now, they're different than good acceptance criteria, which is usually focused on a single thing, a rule or a step of a process. So here's the difference. I might have an acceptance criteria that, this is from Amazon, that if I'm a prime customer, I get an offer of a free 2-day shipping. And I could write a test for that, automate the test and see whether that option is presented to the user at the UI. On the other hand, I might have a landing zone criteria, and you have to think about as an architect, how are you going to instrument it to measure these sorts of things? Selection of, and this is a usability criteria, how would I, people should be able to select shipping options with 99% customer accuracy. So you'd have to track what they did and see whether they reversed what they did. And oftentimes, some landing zone criteria are hard. You have to do some instrumentation to do testing and hooks and make sure that some measurements are aggregated or measured when you're doing things. So as an architect, I might want to create an initial set of landing zone criteria out of, let's say we're supposed to be delivering 30 features over the next 2 months. Do we have any sort of performance targets for these things? Do we have any sort of reliability? What are they? And I want to identify high-risk items and establish target values. I don't necessarily expect product owners to tell me that. If I'm an architect, I might be doing some investigation, or we might know from prior systems that we've built that have done that. And then there might be some trade-offs and costs that I have to deal with. So on an Agile landing zone, as opposed to just a fixed landing zone, which they do at Intel for many of their projects, an Agile landing zone is something that might need to get recalibrated as we're moving along, as we're being Agile. And if we're making a trade-off for performance here, we might make a compromise in flexibility. We need to understand when targets are going to be achieved, and what do we need to do architecturally to achieve some of these targets sometimes. So this is just a snippet from a real system that I worked on with a client. There's loan payments and the transaction time and the consistency between, I can't name what these systems were, but they were certain critical attributes that had to be propagated based on certain transactions, and claim data accuracy. And these numbers were based pretty much on the minimum values, because this was a system replacing the old system, were based on, got to be a little better than the old system, or why are we doing it, right? But the targets were based on things that we would come up with through prototyping or those sorts of activities. One of the things that I encourage you, if you're thinking about landing zones, is that too many criteria and you lose track of what's important, right? So if I have a rolling set of delivery of features, I might have 20 or 30 criteria that I'm looking at. And I may need to organize and group them and break them down into how am I going to actually measure them, because I have to have things I can measure. And Agile means that I need to recalibrate them. Let's say we're not making our performance targets. Do we stop? What do we do? Okay, so just want to talk about we talked about design spikes. I've been involved in teams where we've had to do architecture spikes. And what they are bounded experiments that are slightly longer than this sort of free-for-all, don't know how to do a task. It's really exploring potential solutions for achieving targets. It's not as tactical like on the ground, but you may identify some risks and you're doing these activities. But the bottom line is they're bounded. They're not this infinite experimentation. You might want to try out radical changes before committing them and really radically changing your architecture. In contrast, this is from the Extreme Programming website, where Don Wells talks about XP design spikes, where it's a very simple program, build it to only address the problem under examination, ignore everything else. And actually he says, most spikes are not good enough to keep, so expect to throw it away. So that even, a architecture spike is something where I'm saying I'm doing a bounded experiment, where I may be doing some actual building of not naive code, but prototypes that almost do it the way I'd like to do it. I may be doing some looking outside or investigation of what's out there. I may be doing some experimentation on a different way of configuring that awful Spring stuff that we've been using or whatever. And I don't want everyone to go suffer through my cache ideas until we figure it out. I may be doing some modeling and proving ideas. Usually, architecture spikes are limited. A week, 2 weeks. They have actionable results. Either it gives me information that, yeah, we can do this, or I need a little bit more time. It may adjust the release roadmap. No way can we achieve this performance, right? You wanted us to have that target of 10 billion transactions per second. I can only get you, slightly less. And it might drive out a whole new set of design and development work. Usually, Architecture spikes are done by small teams, not ivory tower, and they produce evidence-based answers, time-boxed. The longest spike I've seen has been around 6 weeks. And what's interesting about, just like in XP spikes, design spikes, an architecture spike can fail too. Gee, we could do this technology, but you know what? It's really a stupid thing to do because it's going to cost us way too much. That's an acceptable answer as well. So another thing to think about is if you are in a larger team or project, you may want to make architecturally relevant tasks visible. I know teams have done it different ways. One way is to directly add certain technical tasks and tag them on your backlog so that they have a different color. We know that those things are not stories. These are technical things that we need to enable what's going to go following on. I've worked with teams and companies where if we have a small architecture and infrastructure team, they have their separate backlog that supports other feature backlogs if you have larger feature teams. Or turning it on its head, if you have a small set of specialists or architects, they may have a workflow queue and the project architecture related work flows through them. Okay. So those are ways of talking about and managing and making architecturally relevant tasks visible. Anything can go through a architecture backlog or a Kanban. It might be some meaty feature that you want to see. Here's the approach that we're going to use this new Cassandra way of doing something. It might be someone has a spike solution that they don't like. I came up with something, but I think we need some more architecture work on this. It may be an investigation, all kinds of things. It may be even developing tools or frameworks. So what do Agile architects do? We're getting to the end of the day. It's 5 o'clock. I'm so happy that you're still here. So what do? They're achieving this balance. Okay? They're figuring out system structure, design approach that allows the system to be sustainably developed. They may need to explain the architecture and draw sketches and convince people of it, but they're doing it in a way that isn't heavy-handed. They're looking at system consistency and integrity and sustainability. And that's not just from an ivory tower. In fact, the architecture landscape, and this is a pretty busy kind of picture here, sure we have development and data and concurrency and system build-out kind of things, but there's also understanding cost trade-offs, and you do some wayfinding into what are the organization and the ops area as well. So although as technical geeks we love to dwell in only this area, I'd say some architects wander around and try to figure out other things too. They're balancing, not just technically competent. And there's a difference between traditional and Agile architecture, what I've seen, that works. Traditional architecture, big picture thinking, produces these big models and blueprints, maybe squawks at you when you do it wrong. They're not necessarily so hands-on, and they're saying, are you doing it right? Whereas Agile is trying to balance the big picture and details, produce what's needed to make informed decision, is hands-on, can get into the code, and is focused on sustainability, which means that sometimes I have to get in there and make things work. They may produce different kinds of models too. There's big M versus little m models in that usually when you're a traditional architect, you create your enterprise architecture view. So how many of those are never finished? They're the ongoing ever story. Whereas in an Agile architectural role, they have models and representations and facts that are intended to communicate and are made to be viewed. And I just have some examples of collected from, the very first little m model was CRC cards by Ward Cunningham, right? All right, now you understand MVC, right? Well, it's a way of telling a story about that. This is a friend of mine who's talked about the responsibilities of various different data stores in their system. So they may produce those to explain to high-end people. But at the end of the day, Agile architects, those people who have that role, care about balance, testable qualities, and they're hands-on. So I'm going to say sustainable development, responsible moments, not just the last scarce moment, evidence-based decisions, attention to detail. And as someone who has a role of Agile architect, you will know that you have succeeded if bugs aren't all over the system. When something is wrong, it's localized. That there are stability around interfaces, that you strive towards that. The insides can change, but the interfaces get there. That there's consistent ways of doing things, that it performs in all the ways that you need. You add new functionality and it doesn't break the existing architecture. And this is one I like, do developers, is there a lot of stinky piles of whatever that they don't like to go to? Then you've kind of failed as an architect. So with that, I'd like to say, I believe there is a role for Agile architects, whether that's a role as a tech lead or someone with an architect in their title. I've given you some practice ideas for small teams that I think a lot of Agile teams just do, and some ideas for larger projects and programs that can help you monitor and make those tasks more evident and visible. So thank you.